Today we're going to talk about the mixing free energy for our polymers in this kind of micelle conformation. So what are we identified the kind of the key free energy terms last time. So one of those was the increase in entropy due to mixing, and specifically we're talking about the mixing of our polymer, homopolymer, the free homopolymer, with the corona. So all type A and all type A in the corona. So no enthalpic terms should be present. So let's take a look. This is our generic Fourier-Huggins mixing term. So what are we mixing here? So let's draw our, here's my corona, or this is my core, excuse me, and then this is my corona. And then we are going to be mixing with free polymer here. So we're talking about the mixing of the free polymer, the free homopolymer in the corona. So what are the species being involved here? Well, it's just species A. So we're only mixing polymer A in the corona. So we are only, there's really only, basically, this is only mixing between a single component. So what is chi AA? Well, that's equal to 0. So we know this enthalpic term is gone. So the only term is the mixing entropy, and this is only really between a single component. So we can ignore enthalpy, and there's only one component, so we can ignore the second mixing term, right? Because if we just have species 1 is equal to A, species 2 is equal to A, we are just looking at basically mixing in the corona the volume fraction of our homopolymer. So this term disappears, and we're left with our delta G of mixing as a function of N naught equals KT of basically phi of our homopolymer, log of the volume fraction of our homopolymer, divided by the degree of polymerization of the homopolymer, where again we have the volume fraction of our homopolymer is 1 minus the volume fraction of our dye block. So we could substitute that in. We also know that NH is equal to N, degree of polymerization of our homopolymer, and here we can see our free energy is divided by N naught. So this is the number of lattice sites, and so it's basically like a type of an effective volume. So we want to get this free energy in terms of the free energy per block copolymer. So we need to divide by the density of the polymers in our corona. So again, to get this kind of effective volume. So if we do that, we know that the density of polymers in our corona is equal to the number of polymers in my micelle, so Nm, divided by total volume of the corona, which we're going to approximate or actually calculate here. So this Rc plus Lc cubed minus Rc cubed, just right here. So we plug that in, we set that equal to, again, effectively your N naught, and we get this expression in the full free energy term right here. That's it. So you could rewrite this again as a function of your pH, pH equals 1 minus phi. And that's it. So that is the free energy for mixing. So next time we're going to get into calculate the free energy of creating that interface. So I'll see you all in the next video. Thanks. Bye.